Hello.
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 Hello. Am I audible?
Yes, sir.
Yeah. So it's starting a bit. So there's just a second. There's an info. Yeah. So we'll start. I was expecting a large audience, but yes, there are very few attendees. So first of all, I'll start with myself. So I am Swastik Sharma. I am a third year PhD student or a PMRF scholar at Indian Institute of Technology, Kanpur, in the Department of Electrical Engineering. So I did my bachelor's in technology in electrical engineering from National Institute of Technology, Srinagar, in 2021. And then I joined here as a direct PhD student. And I am doing my PhD in the area of power systems, especially power market operations. So, so I would like to know a bit about you since there are only 5 of us. So how many of you are from BTech college? I mean, I are currently pursuing BTech. Can anyone raise your hand?
Sir, I'm pursuing Bachelor of Engineering
Oh, where?
from MIT's Bhujbal Knowledge City, Nasik, Maharashtra.
Oh, nice. Which year?
Final year, sir. And also,
Finally.
I had completed my diploma.
Oh, you have completed your diploma and went through a lateral entry, right?
Yeah, from Government Polytechnic, Mumbai.
Oh, nice. So, what made you take this course? I mean, gate preparation.
Yes, sir.
What made you take this course? I mean, is it for gate preparation? That's graduate aptitude
Yes, sir.
test?
Yeah, also for gate preparation and also for my also one MOOC subjects also there in our college that they told us to certify in this course, then submit this certification in our college, then you will be.
Oh, okay. Oh no, I get it. So this is for your
Yeah.
MOOC course, right? Yeah. So you've registered for the exam as well, right? I hope you have registered. I mean, the last date for registration is approaching.
Yes, sir.
Great. So what about rest? Does anyone want to talk? I mean, the forum is open. I mean, uh, you don't have to be shy. I mean, so from industry taking this course, let me ask these questions. Maybe you'll get a bit familiar. So is anybody hearing any background noise? Let me know. I mean, there's raining outside, so I don't have much control over it, but still, I may try to be a bit loud. Okay, so no one wants
No,
to
sir,
talk?
it's okay. It is
Oh,
your voice is okay, sir.
okay. Anyone else? Okay, then we'll start. So the course is fundamental of electrical engineering. It's just familiarization with how we solve electrical circuits. I mean, you must have gone through the week one lectures. I mean, how many of you have gone through that week one lecture? So that is what we are going to discuss today. So this will help you. This will help you in solving that assignment that they have given to you. Anyone? Anyone who hasn't gone through that course? Apart from the exercise, does anyone have any doubts? I mean, if they have doubts, conceptual doubts, I mean, I'm ready to take them. Okay, since there are no doubts, so okay, what about week zero? So there was this practice assignment, week zero assignment. So was everyone able to solve that? Anyone have any questions? I mean, you can say no, you can say yes. I mean, let's make this class a bit lively. I mean,
No, sir.
no, so no questions for week 0. Okay, so week 1. Apart from the exercises, we'll discuss the exercise in detail. Any questions? Conceptually? Okay, so let's discuss what we about that lecture. Maybe it will. My screen is there. Okay. Okay, so we started with basic. What are the different system units in SI quantities or SI quantities for various symbols for various quantities. So this is done. I mean SI prefixes. Charge and current. So does anyone have any question in this? So can I ask you questions if you don't have questions? I mean, would that so maybe asking you questions would make you be more responsive in this class? Hmm? No question. So it was all okay. So can anyone tell me why? So you all know that in our homes we use AC instead of DC. Why is that? Why AC? Why not DC? I mean, does anyone have any answer for that? AC versus DC? No. Okay. So you'll understand about it. I'll go through it. Okay, so we'll start with the exercise. So if there are no questions from this conceptually. So what about the first question? Who solved it? Can anyone tell me who solved it so that I don't have to solve it fully? Do I have to call your names?
No, sir. Not solved this question.
You didn't solve this question. Anyone who solved it? Narayan Patel, Muhammad Abdul Aziz. Anyone? Even brother?
Good evening, sir. Sorry, sir, I didn't solve it.
Oh, you didn't solve. Okay, you can mute yourself. I mean, there's a lot of background noise. Sanket Ravindra. I mean, you can say no. I mean, I'll solve it for you, but I want this class to be a bit lively. I mean, I don't want it's already on online class, so okay, so we'll solve it. So we are required to find current, and we are given the quantity charge. So what's the relation between charge and current? Can anyone tell me? I is equal to what?
The flow of electrons is known as current, sir.
Okay, the flow of electrons is known as current. Okay, anyone else? I mean, I'm talking about the mathematical relation. So can anyone tell me what's the mathematical relation between current and charge?
So charge is in Coulomb.
Okay. So I is equal to dq by dt. It's the rate of flow of charge, correct?
Yes, sir.
Yes, sir.
So what is I? I is basically we tell what is the rate of flow of charge. So we are given the quantity Q. Q is given as 0.41 minus e raised to the power 250 t. So it's a simple differentiation. So what would be the answer? Can anyone tell me? Can anyone just solve it? Okay, Mom. Abdul, can you mute yourself and then unmute yourself when you want to talk? Yes. Can anyone solve this for me? Mayur?
Yes, sir. I will calculate this.
Yeah. Please go. The answer is given over here. So is it correct?
Yes, sir. Wait.
Mm-hmm. Waiting.
Yes, sir. But my answer is wrong, sir. It's coming
Oh,
zero.
just a second. I don't know if I'm pronouncing your name right. Janif, you're not able to hear me? So everyone else is able to hear me. I mean, so you haven't connected to your audio. So there's this button over there, mic. Below that, there must be something related to connect to audio. So can you do that? Can you click on it for me? And then select Wi-Fi or mobile data or whatever you're using right now. Okay. If you're unable to do that, please let me know through that chat box. Okay. So what were you saying? It's coming out to be zero. Hello, Mayur.
Yes, sir.
Okay. So what did you do? Can you walk me through it?
Sir, I just
Okay.
put that value of t on this your equation.
Okay. And the value of t is 0.03, right? Or 0.003, right? 0.003. Can you do one thing? So can you tell me? But for me, it's coming out to be 47.24 milliampere. So what we do is, so you know the chain relation between how to differentiate using chain relation. So we have 0.41 minus e raised to power minus 250t. So we integrate one by one. So 0.4 is common and it's constant. We keep it out. Then one differentiation of one with respect to time is zero because it's a constant. And then for minus e raised to the power minus 250t is simply 250 into e raised to the power minus 250t. So differentiation of EAT is nothing but AEAT. Am I correct?
Yes, sir.
Yeah. So that's what I did. And you put the value of t equals to 3 milliseconds and the answer would be 47.24 million. Okay, so those who have not done this exercise, I'll be adding this to my drive link, which will be sent to you. So it's better if you do it with me. So that in that way, you'll be able to ask more questions than you are currently. So 1.2, who has done it? Who did this? Anyone? Hmm? Did anyone do it? Janif, are you able to hear me? Okay. So I guess no one has done this too, right? Okay, can anyone tell me what's the relation of P? What's the relation between voltage and current in terms of P? So how do you write P in terms of voltage and current? Anyone?
V into
Sir,
I.
P is equal to V into I square into R. Or we can
Okay,
write
okay.
as a.
Yeah. One is sufficient. In
Okay,
terms of
okay.
V and I was writing. Okay, so I here is given as the instantaneous quantity. Whenever you're this is an instantaneous quantity, right? And V is also an instantaneous quantity. What is an instantaneous quantity? Where you are given a relation between a time varying quantity, right? So P as a time varying quantity is simply just V T dot I T. Am I correct?
Yes, sir.
So what's required is to find the total energy transferred during T greater than equal to 0. What's the relation between energy and power? Can anyone tell me?
Energy is denoted as joule and the power is a watt.
Okay, but what is the relation between them? That's a good fact, but what's the relation? I mean, in terms of mathematical operation. Anyone? The forum is open to everyone. Anyone? Okay, so power and so energy is simply integration of PT with respect to DT. Am I correct or is it wrong?
Yes, sir. Correct.
Is it correct? So, so what would the answer be? So, like for example, what is this multiplication? Can anyone do it for me? What would be the final value of PT? I'm bad at multiplying things. Can anyone do it for me?
Yes, sir.
Mhm.
Sir, what's the value of the T?
What's the value of?
T?
No. I don't want you to. So there's no value given right now. I just want you to multiply these two quantities because power is what
Yeah,
V
okay.
into I, right? Yeah, just multiply it and tell me the final quantity what PT would be in terms of T. Everyone is encouraged to do it. Please do it. So since the attendees have increased, so I would request all of you to please contribute in this class. I mean, it'll be make it nicely, make it interactive. I mean, come on. So is everyone able to hear me, right? Janif, you didn't respond. I think that he left. Okay, no worries.
Sir, E of T is equal to integration of V of T into I of T dt.
Yeah, E of T is equals to integration of V of T into I of T dt. Okay. What is the answer? Final value?
So E of T is equal to in bracket of V of T into I of T, something base 0 and rest to something, sir.
Infinity.
Yeah.
Okay. No. I wanted you to calculate what P of T is. So let's calculate it. So it's what 10 e raised to power minus 5 into 10 raised to power 3t into 51 minus e raised to power 5 into 10 raised to power 3t. Okay, so this so what I wanted you to tell me was what is this value? What is the final answer for this equation? So it's like 500 e raised to power minus 5 into 10 raised to power 3t minus, since bases are same, the powers will add. So it will be 10 into 10 raised to power 3t. Done. So now integrate it. So I already told you. So for differentiation, just a second. So my handwriting is visible, right? It's legible. Let me know if it's not. I mean, I'll try to write better. Okay, so now tell me. So since differentiation, I told you E of 80 is what? A into E of 80. What would be the integration? Anyone? Muhammad Abdul Aziz?
Yes, sir.
Shubham Jan? Yeah. What is the integration of E of? So just tell me this. What is this quantity? I mean, what is the final answer for this quantity? This
Sir,
quantity.
A into E power 80, sir.
That is differentiation.
Sorry, sir. Okay, okay.
No worries. No worries. So what would be the integration? I mean, if the differentiation you multiply it, so by integration, what would you do?
So the
You'll
value
divide
is
it, right?
e raised to 80.
Huh? The value is?
E raised to 80.
No. So the value is E80 divided by A.
Okay.
Yeah. So it's not a. So I don't want to delve into integration. How that came into picture. I mean, I'm taking it as given. So because I have to solve 24 questions, so I can't go into integration right now. But the value is, I told you, 1 upon A into A80. So let's break this up. So what? Let's break this up. So 2 minus 5 into 10 raised to power 80 minus 0 to infinity e raised to power minus 1 into 10 raised to power 50. Okay. So who'll solve it? Now I told you what the value of integration would be. Now solve it for me. What's the value of integration? 1 over A, E of 80. So solve it. Anyone? Atharv, can you mute yourself? If you don't want to, if you don't want to, if you don't want him, if you don't have a doubt, please mute yourself. Atharv. Atharv, can you mute yourself? Okay, so what's the answer? Mayur, Abdul, anyone? Shubham, Chaitanya, Krishna. Now call your names.
No, sir. Answer
Narayan,
is not
Sanket.
coming.
Okay, so I'll solve it for you then. It's 500. As I told you, it's nothing but e raised to power minus 5 into 10 raised to power 3. T divided by e raised to power minus 5 into 10 raised to power 3. Sorry, minus 5 into 10 raised to power 3 minus e minus 10 into 10 raised to power 50. Okay, 0 to infinity. 0 to infinity. Okay. So when a decaying exponential goes to infinity, what's the answer? Okay, just tell me what is the answer for this. e raised to power minus infinity. Can anyone tell me what's the answer? What's the answer for this? It's 1 over e raised to power infinity, right? So when in e raised to power infinity is a very large quantity, we sum it to infinity. So what is 1 over infinity?
0, sir.
Yeah, it's 0. So for direct integration, when infinity would be put in, it would be 0. And when 0 would be put, it would be 1, right? E raised to power 0 is 1. Am I correct?
Yes, sir.
Okay, then solve it, and then the answer would come out to be 50 into 10 raised to power minus 3 joules. Anyone, any problems, any doubts?
Sir, sorry, sir. I have some small confusion.
Yeah, tell me.
Sir, how can we take 500, sir?
How can we take
500,
500 is given there?
500. Yeah,
10
sir.
into 50.
Acha, okay. 10 into 50.
Yeah.
Okay, sir.
Because it's VT into IT, right? So 10 into
Yes, sir.
50 is 500. Yeah.
Thank you, sir.
Okay, no worries. So next question. Yeah, this is a very easy question, right? Who'll solve it for me? Come on, please, someone solve it for me. I mean, I don't know the answer for it. I mean, yeah, so answers are given. I don't know the solution, how to solve it. Mayur, Abdul, I'm sorry I'm calling your names again and again because you're the only one responding. I called everyone out, but no one is responding to me, right? Yeah. Go on. Someone was saying. Fresh faces, let me see. Narayan Patel. Okay, no response. Krishna, Ravindra, Deep Jyoti, Ame, no response. Who's this user? Sanchita, no response. Okay, so how will we solve this question then? Abdul, can you tell me?
Sir, I think by using KCL.
No,
Sorry,
we
KVL. Okay.
don't go into KVL yet. I mean, it's good that you're thinking about it, but we didn't discuss it, right? Yet in the
Yeah,
last week.
okay.
So we won't solve it using KCL, but there's a nice way to solve it. I just solved one question. P is equal to what? VI?
Yes, sir. P is equal to VI. Yes, sir.
Yeah. So use P equals to VI and tell me what would be the so there will be two things used in this. One would be simply P is equals to VI, and the second is law of conservation of energy. What is law of conservation of energy? Can anyone tell me?
Energy not be created, neither be created nor be destroyed. Just we can transform one form to another form.
Transfer from one part to another. Okay. So then I've given you the clues. Can anyone solve it? Come on, Abdul, you're very close. So let's solve it together.
I will
So
try,
what's
sir. Yes.
okay? So what is PA? Can you tell me what is PA? So I is what, 2 milliampere?
Yes, sir.
E is 8 volt. So what's PA?
So 0.16.
0.16. I don't. It's not 0.16. It's 16 milliampere is not 0.16. I guess.
Sir, 0.016.
Okay, but we'll write 16 milliwatt. Let it be in
Yes,
millis.
sir.
We don't want to have zeros in here right now.
Okay.
Okay. PB. What is PB? Okay, no, I wrote 16 milliwatt. Is
1
it
milliamp.
correct? Just a second.
Sir?
Is it correct? PA is 16 milliwatt. Is it correct? Am I missing something? Some sign conventions? Okay, so tell me one thing. When power is being absorbed, what's the convention of power?
It will be minus 16.
Yeah, minus. And for for absorbed it's plus, and for delivering it's what? Minus.
Minus.
So here A is delivering this power, right?
Yes,
So
sir.
it would be minus. Okay. Now tell me what would be PV. So I have given you a lot of ideas, so you can think
1
over it now.
milliampere, sir.
That
PB
12.
is equal to
PB is equals to 10 milliampere, 10 milliwatt, not ampere. It's watt now.
No, sir, 12 milliampere. 12.
Well, it's 5. 5 into 2 is 10, right?
yes, sir. Yes, sir.
Yeah. So it's 10 milliwatt.
Yeah.
Now use law of conservation of energy, according to which PA plus PB plus PX should be equal to 0. So what is PX now? It's simply minus of PA plus PB, which is 6 milliwatt. Okay. Okay, so you got PX is 6 milliwatt. Now it's asking what is voltage. So what's the relation between power and current in terms of voltage?
V square by R, sir.
No. In terms of power and
V
current, I'm
equal to
asking.
V into I.
It's simply V equals to V. I have written it over here. So
Yes,
then,
yes, sir. Sorry.
voltage at X would be what? 6 milliwatt divided by 2 milliampere, which is what? 3 volts. Done? Any questions? I hope there are no questions. Okay. So
Okay.
1.4. So it's a similar question. Now it's asking, it has given me currents less than t less than 0, it's 0. And from t greater than equal to 0, it's 20 e raised to power minus 5000 t. So we have to determine the total charge entering the element. So again, what is I in terms of Q?
dq by dt.
dq by dt.
And what is Q in terms of I then?
Integration.
Yeah, I dt. So for less than 0, it's 0. So I am not taking it. So from 0 to infinity, it is what? 20 e raised to power minus 5000 t dt. Am I correct?
Yes,
So
sir.
now I've given you enough information how to integrate this. Can anyone integrate this for me, please? I'm bad at it. I'm very bad.
Sorry, sir, but I have one more doubt, sir.
Yeah.
Sir, why?
You don't have to be sorry for it. Yeah.
Sir, why we are taking limits 0 to infinity, sir?
Okay. See, it has given that from t less than 0, I is 0.
Yes,
T
sir.
less than 0. And from t greater than 0, it hasn't given us till what value. So we'll assume it's asking of infinity. In either way, it's t greater than equal to 0, right? So when we write integration, we write minus infinity to infinity. But since from minus infinity to 0, it's 0, we won't take that integral into account. So that's why we start from 0 to infinity.
Okay, sir.
Okay. Yeah. So now do this integration. I mean, I just solved it. So can anyone solve it?
Sir, the answer is 20, no?
No, the answer is already given. It's given 4000 into 10 raised to power minus 6. But yeah, let me tell me how you did that. I mean, it's good that you got something.
I
Can you
put
tell me?
t is equal to 0, sir.
Oh, okay, but first you have to solve this integration, right? What's the solution for this integration? Let's go step by step. So what will I do now? And the next step, how to solve this integration? Can anyone tell me?
Sir, take constant 20 outside.
Okay.
Integration 0 to infinity.
Okay. And then minus 5000
E power
t.
minus divided by.
Okay. The next question would be divided. Okay, I'll divide it. So it
yes.
would be what? Minus 5000 e raised to e raised to power minus 5000 t, 0 to infinity. What will be the answer now? So for infinity, what is this value? E raised to power minus 5000 t? Zero? Is it zero? Okay, there are new people in this meeting now. Let me ask them. So Sejal, Shraddha, Tahir, Sahil, Redmi 9A, I don't know who this is. Priyanka, Pratiksha, Narayan was here, he's not responding. Mutsili was here, he wasn't responding. Krishna is here. Deep Jyoti, Amay, Shubham Jadhav, and Anusuya. Can anyone respond? What would be the answer after putting these integral?
Sir, may I, sir? 4 into 10 to the power of minus 3, sir.
4 into 10 raised to the power of minus 3. Very good. So for others, I'll do it once. So e raised to the power, so when I do this, into infinity divided by minus 5000 minus of e raised to the power minus 5000 into 0 divided by minus 5000. So this is 0, right? Anyone who has a problem with this? This is 0, the first part, because it's a decaying exponential function, and as t tends to infinity, this will tend to 0. And the other part, since it's e raised to power 0 technically, then it would simply be 1. So which is 20 over, since minus minus is plus, 1 upon 5000, which is nothing but 4 into 10 raised to power 3 coulombs. Just remember to put the signs correctly. I mean, these the notations should be correct. Otherwise, people can ask. Okay, next question. It's very easy. So who will answer this for me? So the question goes like this. Assume that a 20-volt voltage drop occurs across an element from terminal 2 to 1. Okay, and that a current of 4 ampere enters terminal 2. Okay. Specify the values of V and I for the polarity reference shown in figure 126. Okay, this is the figure. Okay, so who will tell me now? Anyone? Mayur?
Yes, sir.
Yeah, so can you solve it for me? I mean, can you walk through how this question can be solved?
Yes, sir.
Yeah. Go ahead. Mm-hmm. So tell me one thing. So there are solved exercise example problems inside this PDF as well, the lecture 1 material. Who all went through it?
Yeah, okay, sir.
No. Okay, no. I'm asking who all went through it. I mean, did you go through it?
Yes, sir, we will.
No, you would, but you didn't go through it, right? Abdul, did you go through it?
No, sir. I will go through.
Nobody went through it. I mean, if you would have went through it, this class would have been a bit, what you can say, a bit lively. So anyways, I have to solve these questions because these are the week 1 would end soon. So tell me, for 20-volt voltage drop across an element from terminal 2 to 1, and the current enters terminal 2. So what is the convention that they are telling? Can anyone tell me? Okay, so just tell me what would be the plus, where would plus go, where would minus go, and where would this arrow go for the current? Can anyone tell me? Hmm? Okay, so I'll solve it. So it's saying
Current
20,
entering and going, sir.
So it's saying 20 volt voltage drop occurs across an element from terminal 2 to 1. Okay. So if it's saying that it's 2 to 1, so how will you write it? So V2 is at what potential and V1 is at what potential? Okay, so I see Shubham Jadhav is turning on his camera but not speaking. So Shubham. Okay, Anusuya. So you raised your hand. Do you have a doubt?
Sir, V2 is at positive potential and V1 is at negative potential because current is flowing through it.
So V1 is in what potential? I didn't go. Can you go through it once more?
V2 is at positive potential and V1 is at negative potential. That is a lower potential.
Okay, and the current is coming out of or coming or going into which terminal?
Current is going to terminal 2, that is at positive potential, higher potential.
Okay, so current is going through this terminal. So now tell me, what would be the polarity of V or value of V in correct polarity?
Here it would be minus 20 volt.
Okay, V is equals to minus 20 and I equals to?
Minus 2.
Minus 4.
Minus
4 is the, yeah. So for the second one, who'll solve it? I mean, this polarity will stay the same. Now you just have to use the sign convention correctly. Who'll do it?
Minus
Abdul?
20 and 4.
Okay, minus 20 and 4. So what's happening? I'll tell you. I won't assume that you know the answer because it won't be sufficient. So let's see. So it's saying that I is entering terminal 2, right? So if it's entering terminal 2, it's leaving terminal 1. Am I correct? So since the sign is so the I what I is given the correction direction of going inside the terminal 1. But since I know that's not correct, so that means what convention it has used? The I is of reverse polarity. Hence, I've written that I is equal to minus 4 ampere. So the similar thing will happen with V as well. So I know V is what? So the polarity won't change, right? It's the same voltage, same difference between 2 and 1. So V would also be at reverse polarity. That's why I wrote minus sign in front of it. So the similar thing will happen if so I is coming out of terminal 1 and the direction is correct. So I is what? 4 ampere. And voltage is at reverse polarity, so minus 20 volt. And for the second, it's like voltage is in correct direction and the current is in opposite direction. And for this, for D part, the voltage is in correct direction and the current is also in correct direction. So does anyone have any doubt in that? Okay, now tell me
No,
if
sir,
it's
clear.
okay. Now tell me if this element is absorbing or delivering power, and tell me why you think so. Because the answer is given, but I want to know how what your thinking is. Anushya, since you were answering the question, so I would like you to go ahead.
So as current is entering from the positive potential and leaving from the lower potential, so the circuit must be absorbing power.
Okay, so it's absorbing power, and what is the power that it's absorbing?
That is 20 into 480 watt.
80 watt, correct. Okay, so anyone who has questions, any doubts? Any doubt? So it's already 1 hour and we haven't gone through 5 questions. So I'll be happy if you will engage more. It would be a nice learning experience for me as well. So 1.6, can anyone solve it for me? What does it say? Okay, so Abdul, tell me what's the question saying and what does it want?
We have to calculate energy
Yeah, we have to calculate energy, but what is given and what's not given? Can you tell me?
Voltage is given, sir.
And current is also given or isn't given? It's not given. Tell me. I don't know.
Yeah, sir.
Current is given, right? What's the
Current
current?
is given.
What's the value of current? So it's asking me to go back to 1.4 problem.
1.4. Yes, sir.
So let me know what's the current. If you must have opened your books, right? Your lecture material.
20.
Yes.
Tell me what's the current. Yeah, someone was
20
saying
into 20 into e power minus 5000 t.
okay. For what? For t greater than equal to 0. Okay.
Same limits
now,
we can apply, sir.
yeah. So how do you solve this question again? Walk me through it. What is power in terms of energy? Oh, sorry, energy in terms of power. So let me know. So if V and I is given, what can be found out from V and I? Anushya, what can be found
Power.
out from V and I? Power. What is power? What is power?
V into I.
Yes. So from
And
power,
then
what you can, yeah.
Power into dt will give us energy for that instantaneous period.
Yeah, it's 0 to infinity, P of t dt. So solve it. Just tell me the final answer is given. So what's the point? So tell me what would come in the inside the integration? And it's easy, right? So if someone is in TF, can you tell me what's 20? What exactly am I expecting in this equation?
$200 can be taken out.
Okay.
And
We can add it inside.
into 10 to the power 3 because it is in kilovolt.
Okay. Okay, so it's in kilovolt. Oh, I don't know what was it was ampere, then it's kilowatt, right?
Yeah, so into 10 to the power 3.
Hmm. Okay, so solve it. Mayur, do you have a pen and paper? Can you solve it for me?
Yes, sir.
Yeah. Go ahead. Solve it. If you have added answer. So what's the
Sir,
how will we write the
200 is
integration?
coming. So my answer is 200 is coming.
Okay, that's not correct.
The equation is minus 200 into e to the power minus 10 into 10 to the power 3t by minus 10 into 10 to the power 3t. Yes.
Yeah. So it would come out to be minus 200, 0 minus 1 upon 10 into 10 raised to power 3. I don't have to write t. So it's nothing but what is it? What is it? The final answer?
20.
No, 20 is joules. This is not 20. This is 0.02 kilowatt. Am I correct?
Yes. Yes.
Oh, sorry, kilowatt second. Yeah. So now, if it's kilowatt second, what's how do we write this in joule?
Yes, sir.
In
Can you
Correct.
tell me?
10 to the power 3. Watt second is joule.
Yeah. So it's 20 joules. Okay, so 1.7. What does this question say? Can anyone tell me? Mayur, I want you to tell me what's the question and I want you to answer it. We'll do it together, buddy. Come on.
Yes, sir.
Mhm. What is the question? Can you read the question out for me and everyone? More people joining. So, Ame, Sanket, Ravindra, anyone who wants to answer? Yeah, Ame, you unmuted yourself. So,
Yeah. So
Mhm.
A is invalid because the polarity.
No, that will go through one by one. What is the question saying? What do we have to do?
So which interconnections are valid and which valid constraint imposed by the ideal sources?
Okay, so what is the first one? So let's go to the first one. So what is it? Is it valid or invalid?
Invalid.
Why is it invalid?
The voltages polarities are at one is actually it's valid. Sorry,
It is
cannot.
valid.
It is valid.
It is valid because the polarity of one with the polarity of one, just a second. The polarity of one is positive and the polarity of two is also is negative, which is same for both the ideal sources, right?
Yes.
So the interconnection is correct and we are not violating any laws.
Yes.
So walk me through the next part. B, is it valid or invalid?
Again, it's valid, sir. The current direction is same, so it is valid.
Okay, I'll write valid. Valid. And what about C?
So the voltage polarities are different, which cannot occur, which is invalid.
What about D?
Again, the current sources are having different ampere volt, so it's invalid.
Okay, and what about E?
E is valid, but I cannot say why, but seems valid.
No, you can say why. I want you to say why valid. Why? Because see, valid is given in the solution itself. So, but I want you to know why it's valid, why it's not valid. So, good. Tell me one, anything that you can think of.
No, sir, but it's the directions.
It's not about the direction. I mean, the 5
Valid.
ampere could also be supplying. Currently, it's absorbing, right? Or is it it's supplying? We can't tell really what's happening right now. But
Pardon, sir?
so can we tell what the 5 ampere is going through? Is it absorbing or delivering? Anusuya?
5 ampere is being delivered, I guess, because it is leaving the positive terminal.
It's leaving the positive. 5 ampere is leaving from the positive terminal. I don't know if you're correct.
Sir, in diagram D, the 3 ampere current is consuming. So it's maybe.
I don't get you what you're saying. Okay, what is the polarity of 1? Positive. What is the polarity of 2? Negative. So what is the polarity over here? These 3 points are in same contact, right? So this is negative. So current is entering the positive terminal and leaving from the negative. What does it mean? Is it absorbing or is it delivering? Anushya?
It is absorbing.
Yeah, it's absorbing, right? So you don't have to. So if it's absorbing, we can't say really, like, for example, if I change the polarities now and it's the reverse, right? Then it would be delivering too. But still, from that point of view, you can't say if it's if it's valid interconnection or not. This is valid because the voltage source and the current source are complementing each other. Am I correct? Any doubts?
Sir, I didn't get. Please, sir, please.
So what Amey said because it's absorbing, it is a correct or valid, circuit. But I'm saying, what if I reverse the polarities now? Does it become invalid? No, because still they're complementing each other. So we talk about valid or invalid through the voltage at the terminals, right? So, like for example, why C is invalid? Because the terminal voltages are not because of terminal voltages have to be same for both, and you can't interconnect if the terminal voltages are different. So that's why the circuit C is invalid. But E, So I told you enough. I've given you enough information to tell why E is valid. Am I right? Any doubt you can ask freely. Anusuya.
Yes, sir.
Yeah. So tell me if what I'm making is making sense to you.
Yes, sir, it's okay.
So is it a valid circuit or an invalid circuit?
It's a valid circuit.
It is a valid circuit. So anyone who has a problem in that can please unmute themselves and let me know. Okay, so we'll move ahead 1.8 then. So we've done it multiple times now. So I want someone from you to do it. Who will do it? Ame, can you solve it for
Sir.
me? Yeah. Who was saying? Who was speaking something?
Yes, sir. Can you please tell me again a 1.7 question? It's all
Yeah.
of jumbling for me.
What is happening?
Sir, it's jumbling, sir.
Jumbling. Okay, let's go through it one by one then. So there was a solved example inside that book as well, the lecture material as well. I forgot if there was. I think there was one solved example, I guess. So did you go through it? It was the same to figure out whether a circuit is valid or not. Okay, so first of all, tell me if there was this example there or not. I mean, I can check. Let me see. Okay, so we'll solve this first. So what are dependent sources? Mayur, can you tell me what are dependent sources? Mayur?
Yes, sir.
What are dependent sources?
Sir, the voltage and current, it depends on the component.
Okay, so dependent sources are those sources which or let's say, or I'll differentiate between both. So voltage dependent sources are those sources where the voltage is dependent on a quantity inside that electrical circuit. Let's say, for example, this 4V. This is a dependent circuit, and dependent circuit are marked by diamond shapes. Always your dependent sources are marked by a diamond shape. So it's saying Vs is dependent on V. V is what? This voltage, right? So what is Vs over here? Can anyone tell me? It's simple maths, right? Vs is what? Mayur,
20.
Vs is what?
20.
Yeah, Vs is 20. So we write Vs is equals to 20 volt. Now tell me, can so 1 and 2 are interconnected and they have so they are connected to same polarities. So can there be a difference in voltages between them, or do they have to have same voltages? So let's say voltage is same voltages, right? Because they are supplying it to the same terminals. But the voltage here is different. Am I right? One is 5 volt and the other is 20 volt. So what is this circuit? Is it valid or invalid? Because they are supplying the same terminals, the voltages have to be same. So it's not same over here, is it? Mayur?
So it's maybe, sir, valid, sir, maybe.
Why valid? Across the same terminals 1 and 2, the voltages are same, right? Voltages have to be same. But here the voltages are different. One is 5 volt and the other is 20 volt. So how can it be valid?
So invalid, sir.
Yeah, invalid. Now you go through the second part. Can you let me tell me what is the value of IS?
10.
10 ampere, right?
10 ampere.
So now tell me if this circuit is valid or not.
Valid, sir.
Valid.
Why is it valid? Why is it
Same,
valid?
sir. The
Voltage
same, sir.
and
At 1 and
current
2
are
point.
complementing each other.
Okay, so you're using what I was saying. So yeah, you can say that. And so it's a valid circuit. Now can you go through the third part, C part? So what is Vs over here?
Eight 8 volts.
8 volts. So this is plus, this is minus. Is it a valid or an invalid circuit?
Valid, sir.
Valid. Now tell me this D part. Mayur will answer this question because Mayur had the doubt, it was jumbling all right. So what is Ix, Mayur? 9
9, sir.
ampere, right?
Yes, sir.
So Is is a independent current source. Am I correct?
No, sir. Dependent.
Is, this one.
Yeah, is independent.
Independent, and Ix is a dependent source. Done. So Is is supplying how much current to 1 and 2 terminal?
Sir, 3 ampere.
3 ampere is coming over here. And what is Ix trying to supply?
Is also, sir, total 9 ampere is there.
9 ampere. So can there be so can there be a difference in so can there be different currents in this terminals 1 and 2?
Yes, sir.
No, it can't, because there's a independent current source, right? How can there be a difference in the currents over here? An independent current source supplies the same amount of current. Am I right?
Yes, sir.
So let's say if this is a correct circuit, how much current is going here then? 9 ampere. But what is this? This is an independent source and it's supplying 3 ampere. Can it be an allowable connection?
No, sir.
No, then this is invalid. So the same thing goes over here too. So I wanted to solve this because that was based on current sources and this is based on voltage sources. So I mean both are there. So is it correct now? Are you getting why the ETH part is a valid circuit?
Yes, sir. Now I get it.
Yeah. So let's go through 8th question. So who will solve it for me? I did it 3 times now. So I guess everyone should know how to solve it. So what are the first steps? Amay, tell me what are the first steps?
So PT is equal to VT into IT.
PT is equals to VT into IT. What is that then?
1200 cos square of 4T.
1200 cos square of 4T. So now what are we required to find?
Energy absorbed by the element in 2 seconds.
Okay. So what is energy in terms of PT?
Integration of PT.
0 to what?
2.
0 to 2 PT dt. So can you do this integration, Amit?
No, sir. Trigonometry.
Why?
Trigonometry is weak, sir.
Trigonometry is weak. Okay, who knows what's what? So how can we solve this question, Anusuya?
We have to substitute cos 2x equals to 2 cos square x minus 1.
Okay.
So from there we get cos 2t plus 1 by 2.
So your voice is a bit loud. So can you just take your microphone away from you a bit? I'm not able to hear you correctly.
It will be
Yeah.
cos 2t plus 1 by 2.
Cos 2t plus 1 by
2.
So anyone who has a problem with this, is it correct? Ame?
It will
Not
be cos
sure.
8t. Sir, it will be cos 8t.
Cos what t? I'm unable to hear you, Anusha. What did you say?
Sir, it will be cos 8t plus 1 by 2.
8t. Okay, I'll do it 8t then. Can anyone tell me if it's correct or wrong? Ame?
Sorry, sir.
Okay, so who else is there? Let me open. Yeah, who else is there? Muhammad Abdul Aziz. He's not here. Kiran Ingole. Kiran?
Sorry, sir,
Oh.
I have no idea.
You have no idea. Okay, then who is there? Sejal Likhar. Can you tell me if this what I've written is correct or wrong? I mean, what is the integration? How can you decompose cos squared 40 in terms of cos t or even sin t?
The formula of cos square theta.
Cos squared theta is what?
Cos 2 theta upon 2. Yeah.
Okay. So how is cos square x written? I'll let you know. It's nothing but if you how to decompose it. Okay. So cos square x is nothing but 1 upon 2 cos of 2x plus 1. Okay. So according to this, can anyone tell me what I've written is correct or wrong? Anyone? What is x? 40. What have I written? Sorry, why is there written 2 over here? I should okay. What I've written is correct or wrong? No response. Okay, this is correct, right? So let's go ahead with the integration now. Anusuya, can you do the integration for me?
It will be sine 8t by 8 plus t, 0 to 2.
What is sine 80 by
8.
okay 0 to 2. You're missing one more part, but it's all
Plus
right. 6. Yeah. Okay, now solve it, please. Someone could solve it for me. So remember, if you have a scientific calculator, this would be in terms of radians, right? I'll solve it. Did it go wrong? So what did the answer come? And can anyone tell me? Anusia, what was your answer? Ame? Mayur? It's simply you have to do it on your calculators, right? Can anyone solve it?
So 4.01 something.
4.01. No. This one by 2. Anushya? Anyone? Did anyone solve it? Hello? Okay, so no answer. So then I have to do it on my. Okay. 600 sign off. Okay, so my answer is coming out to be 1.7 2 seconds. So we will do cos 80 plus 1 by 2 dt. Correct? Yeah, so 2 600. So my answer is coming out to be a bit different than what's given. Sine 8 into 2 divided by 8 is what? Minus 0.0. Since sine 0 is what? 0. So I'm not doing that. Plus t minus, so 2 minus 0 is 2. So what is this? This comes out to be 600 into 0.036 plus 2. My answer is 1178.4. Anyone else getting the same answer? Anusaya, are you getting the same answer?
Sir, I am getting 1220.6.
1220.6. Taking the same, so you got the same equation, right? Sine 8 t by 8
Yes,
from
sir.
0 to 2 plus t 0 to 2. Did you
Sir,
change your calculator?
Sir, I'll do it once more.
Yeah. Did you change your calculator from degrees to radians? I mean, it's important because these are in radians. The quantities are in radians.
Sir, one minute.
Mhm. Ame, I hope you have a calculator. Can you solve it for me?
It's not with me right now.
Okay, but you have a computer, you have a mobile, you have
I'll try.
something. Yeah, try please. Yeah. I want someone to validate it so that if this answer is wrong or not, I'm pretty sure if it's. Anusuya, did you get the same answer now, or is there some problem?
Sir, 1 minute.
Yeah. Take your time. Okay, so you can solve it later. I mean, we are getting late. So let's start with this question. I mean, this is very easy. A stove element draws 15 ampere when connected to a 120 volt line. How long does it take to consume 30,000 joules? So, Ame, let's start with you. What is E in terms of P? Don't tell me in terms of integration. I mean, just E is what?
Sir, the previous answer will be 20.56 degree to radiant.
20.56 degree to radian?
So I'm still getting 1200 itself, the answer.
1200. Okay, but you're using 600 sine 80 t divided by 8. This equation is correct, right? This one, this part. This is correct.
Yes, sir.
Yeah, that's all I want to know. I'll solve it once more when I send you this file, and then we can validate it. But I guess this is the correct answer. But I'll again go through it now. So what is E in terms of P? P and time. Can anyone tell me? Ame. Anyone? Cos square theta formula. I'm pretty sure cos square theta is what? Cos square theta plus sin square theta is 1. Cos 2x is 2. Cos 3x. This is correct. What we have written is correct. 1 plus cos 2x by 2. So I guess that's what I've written. Oh, you're saying cos 2x by 2 only. I mean, it won't come under 1. What to say?
So 1 minus sin square theta, cos square theta is equal to
Cos square theta is equals to 1 minus sin square theta. That's correct. But we want in terms of, we have written 2 cos 2x plus 1 by 2. Have we written 2 cos 2x plus 1 by 2? No, I've written cos 2x plus 1 by 2 only, right? I guess this is correct. I mean, with Selvi, you can go through it once more. Okay, so we'll go through 1.9 then. You tell me, if a stove element is drawing 15 ampere and it's connected to a 120 volt line, what is the power? Ame? Anyone?
1800.
1800?
1800.
Oh, 180. Okay, 1800. What? 1800 watts.
Watts.
Now, yeah. So joules is what? Watt second, right? So energy it's given, it would consume 30,000 joules, or we can write 30,000 watt second. So we need to find time. So E is just P dot T. Am I correct if we're talking about constants? So T is E by P, and the answer would be 30,000 divided by 1800, which comes out to be 16.67 seconds. Great.
Yes,
So
sir.
1 point, yeah. So 1.10. So can anyone tell me what is what is the equation again? I'm asking you again and again. I guess it would be in your brain by now. So what is I in terms of Q?
dq by dt.
Yeah. So then what is Q in terms of I?
Integration of
Integration of I dt.
ID of t.
I. So when I say integration, what exactly is it? It's when I have a waveform, and when I say integrate it, what exactly am I asking from you?
Area under the curve.
Area under the curve, exactly. So at t equals to 1 second, what is the area under the curve? Can anyone tell me?
10.
So, just a second. So this area is 10. Now, Ame,
Yes, sir.
yeah. For 1 to 2, what is the area under the curve? What you can do is you can divide it. It would become a rectangle and a triangle. So can you tell me what is the area under the triangle?
Half into 5 by 1. So
Half
2.5.
what is it? 2.5. And what is this?
5.
5. Great. So what exactly is the okay, so now next is t equals to 3. What is the area, this area then? Can you tell me?
5.
This is 5. And
Again.
what is again 5?
5.
Now tell me last, this one.
2.5.
Great. So for t equals to 1, it's just 10 coulomb. Am I correct?
Yes, sir.
And for t equals to 3, it would be how much?
3.
Up until here.
5 plus.
So 10 plus 7.5 plus 5, which exactly is 22.5, correct?
Yes, sir.
Okay. And then for t equals to 5 seconds, how much is it? You add 7.5 to that, right?
Yes.
And then 30 coulomb. Okay, great. So 1.11. Who will tell me? Now it's done. Poonam. Poonam, can you hear me? Can you unmute yourself?
Sir, sorry, I recently just joined now. That's why.
No worries, but you must have gone through that week 1 lectures, right?
Yes, sir.
Yeah. So can you just tell me what exactly is this question asking? So it's, what is it asking? I mean, just go through the question. I mean, just read it out if you can.
Yes, sir. Two electric circuits represented by two boxes A and B are connected as just one second. Are connected as shown in figure 1.29 for each of the following sets of values. Determine the power and state whether the power is falling from A to B or B to A.
Okay, great. So now tell me, so we just have to determine the power and we have to tell where is it flowing from. So for A part, the direction of current is confirmed and the voltage is 120 volts. So what exactly is the power between the two circuits? P is what? P is VI, right, Poonam?
Yes, sir.
So since they are confirming the so what exactly is the power then? Just multiply, right? 120 into 5. This comes out to be 600. And the notation of current is denoting from A to B, and it's entering the positive terminal of B. Am I correct? So the power is flowing from where to where? A to B, right? Right?
Yes, sir.
Yeah. For B, what is the power? It's given. The answers are given, right? Let me just remove the answer. Okay. So the current direction of current is so the current magnitude is 8 ampere and its direction is in the is with the reverse polarity. So what is the power? 8 into 250, which is what? Poonam, 8 into 250.
Yes, sir. Just one. 2000.
Yeah. So what's the direction? let me, so just
It's
tell me
minus
one
8.
thing. Pooja,
It's minus
yeah,
8.
I'll go through it. Just one question. So let's assume this. So with this, you don't know the value of current, you don't know the value of voltage. Okay, you just know the direction and the polarity. So from this figure, where is the power flowing from? Anusuya, where is the power flowing from? Just from this figure. Don't care about. I don't care about the magnitudes and directions of the voltage. Sorry, I don't care about what the values of voltage and current are. From this figure, the direction is given from A to B. The current direction is given from A to B, and it's entering the positive terminal of B. So where is the power flowing from? From
A to B.
A to B, correct. So just remember this, and when, so that's why if the answer comes out to be, so let's say, so I is what, 5 ampere, the direction is same, and the voltages are same, the direction is same. So the power comes out to be 600 watt, it's flowing from A to B. Now the voltage power, this current is negative, right? And it's coming out to be minus 2000 volts. So what does that mean? The current is now flowing from Anusuya,
B to A.
Puna, B to A. So same with the C part. Can anyone tell me what's the direction and what's the power? Poonam,
Yes, sir.
what's the power? What's the direction?
4800, and it's
Okay.
A to B.
Okay, great. And for D, what's the power and what's the direction?
Uh, 2400 ampere, and it's B to A.
B to A. Okay. So let's go to the second question, 1.12. Okay. So now tell me, anyone who has solved this question? Amit, can you tell me how will we solve this question? Okay, so we'll do one thing. This is a very interesting question. I have solved it. I'll do only A part. B part, I'll ask you the next time. It's a good question. If you don't have a refresher over your integration skills, it's a good refresher over that. And I'll ask you to go through it once, please. And the next session, I'll do a detailed solution. And even I'll post it because I'll anyways be sharing you these this material. But then again, if you try it, it would be good. And if you're giving exams just like Mayur, so it would be better for you if you solve it. So let's go through it now. What is P in terms of V and I? Poonam,
Yes, sir.
what is P in terms of V and I? P equals to VI, right? Am I right? Okay, so can anyone tell me what would be the final form of this equation? Anusuya, go ahead.
Yes, sir.
Yeah, what
2000
would be?
integration 0 to infinity 2000 e to the power minus 100 t sine square 150 t watt.
Yeah. So we are not doing integration. We are interested in finding the power absorbed. Okay. So PT is what now? Tell me. You just have to put t equals to 0.02 seconds. Can anyone do that for me? Just put and find the answer. I am also doing it. Remember, your calculators must be in radians to solve these problems.
Sir, 5.390.
Anyone else?
Sir, T is equal to 0.02, na?
Yeah, T equals to 0.02. I'm just confirming it with everyone. Ame, did you do it? No one did it. Anusuya? PT is what?
So I'm getting
Eh.
5.3 something 5.39.
5.9. Go through the fourth, go up till the fourth decimal point. I need to know so if you have solved it or not. Because the answer is given 5.39, but can you go to the fourth decimal point? $5.3904.
5390.36.
Okay, someone has already written 5.39036. Great. Okay, 36, we can round it off to 4. What? So as I told you, the next energy absorbed is what? ET is what? Integration over PT dt. Right. Now you'll see one thing here, E minus 100t and sine square t are in multiplication. And there's no such thing as chain rule in integration. So for this, you have to do substitution. Okay. So how will you substitute? Because I want you to do this is because your week 1 assignment will have similar question. So I don't want to solve this and then you go through it and you'll just you won't do it yourself, right? So go through it, solve it for ET, and then we can discuss it once the or I'll submit. Okay, we'll discuss it in the next lecture. 1.13, and it's a bit long too, so I don't want to cover it because we don't have time. 1.13, and it's just integration. Okay, so Ame, 1.13, come on. Ame?
Yes, sir.
Yeah, go through the 1.13 question.
For the circuit connection, determine P1, P2, and P3 for I equal to 2 ampere, I equal to
minus 3 ampere.
minus 3
So
ampere.
yeah, you just do it for 2 ampere. So how will we solve it? Can you tell me?
So, P1, P2.
Okay, so first let's define the polarities. So this is plus minus, this is done. So what about P1? What is the polarity of the P1 element? It's plus and minus over here, right?
Yes.
Yes. So now tell me, so the P1, what would P1 be? So if I is over here going coming from the negative terminal, so what is P1? Positive or negative?
Negative.
Just a second. What did you say?
Negative.
Is it negative? So Anusuya,
Yes, sir.
what would it be?
So it will be positive.
Okay. So it's 8 into I. What is I? Ame?
2 ampere.
2. So what is the final value? 16 watts. Correct?
Yes.
Let's do for P3. Now tell me what's P3. Come on, Ame. I know you can do this.
Pardon, sir?
I is entering the negative terminal and coming out of positive terminal. So what is the power?
6. We don't have watt here.
10 volt. It's P3. I'm talking about this element.
Acha, P3. Okay.
Yeah.
I is 2, so 20.
Plus or minus?
Minus.
Okay. Why is that?
It's leaving plus sign.
Okay. Now tell me P2.
Voltage is 6I, so that would be 12 ampere. 12 volt.
No, okay, 12 volt. Okay. And what is
I is 2.
and what is
24
it?
volt.
Is it just a second? Just a second. 12 into 2. Now tell me about the signs. What would be the sign over here? Negative or positive? Is it absorbing or is it delivering or supplying?
It's delivering, so negative.
Negative. Great. So it's negative 24 watt. Okay. Now the same thing can happen with I equals to minus 3 ampere. That I'm not going to solve because it's the same thing, right? You'll be able to do it. 1.14. Let's do it. So now should I ask Sejal? Sejal, can you solve 1.14 for me? Can you walk through it? Walk through it for me. Sejal. Not interested, I guess. Shubham Jadhav, Sanket Ravindra, Anusuya. I'm sorry, I'm going to you again and again because you're the only one answering. So how would we solve this question?
V into I.
V into I, correct? So walk me through it. What should I do? Just
It
do
will
V
be
into I.
no 8 into 10 to the power minus 3 watt. That is 0.08 watt. So it is
That's correct.
delivering power as it is leaving to the positive terminal, so it will be negative.
Yes, it's delivering power. So it's minus 0.08 watt. And for the second B equals to 10 B part, what is the answer?
The direction of current is reversed, so it will be absorbing power, so it is positive now.
Yeah, correct. So anyone who has a doubt in this, can anyone tell me if you have a doubt? Ame, did you understand it? It's simple, right?
Sir, but can you repeat just once, please?
Okay, I'll do it. So voltage, the polarity of voltage is plus, so plus over here and minus over here, right?
Yes, sir.
Yeah. So now tell me, what is the voltage V? 4 volt.
V is 10 volts. Achha, 4 volt, 4 volt.
4 volt. What is I?
I is 2 into 10 is to minus 3 amp. 2 milliamp.
2 milliamp. Just a second. Okay. So it's leaving from the positive terminal, am I right?
Yes, sir.
So it's delivering power.
Okay, got it.
So then it would be 2 into 10 raised to the power minus 3 into 4.
Okay.
Yeah. And
Yes,
which is minus 0.008 watt. For
got
the
it.
second part, the current direction is reversed. So it is now absorbing the power and it's absorbing 150 watts.
Got it, sir.
Correct? Mayur, do you understand it?
Yes, sir.
Yeah. 1.15. Okay. Tell me what is VT. I've done this enough, so I want someone to do it. IT is given as 3e raised to power minus 2t. है ना हमें? हमें? Poonam? Mayur? Am I online? Yeah, am I on? What is VT? 5 di by dt, right? Can anyone tell me what would be the value of, what's the expression of VT after doing this differentiation? Ame? Okay. Sejal? Anusuya?
Minus 30 e to the power minus 2t.
Okay. 5 t e minus 2t dt, which is minus 6 and 30. Minus 30 e raised to the power minus 2t. Correct? Yeah. So what is it asking? Just a second, I'll remove the answer. So the first thing is asking the charge delivered to the device between t equals to 0 and t equals to 2 seconds. Okay. So charge is what in terms of it is given as 0 to 2 it dt. So what is the expression of qt after solving this integration, Anusuya?
E to the power E into 3 into e to the power minus 2t by minus 2, 0 to 2.
Minus to 0 to 2. Okay, solve it. It would be 3e minus 4 divided by minus 2 minus 3e. Oh, it's 1. 0, 3 by minus 2, right? So what's the answer? What's the answer?
One 1.47.
Okay, 1.47. Okay. Coulomb, right? Coulombs, right? Anusuya,
Yes.
did you get the same answer?
1.4725.
Great, great. So let's solve the B part. What is B? B says the power absorbed. So what exactly is power? PT equals to VT into IT. So what would be the equation? Minus 90 e raised to the power minus 40. Is it correct?
Yes, sir.
Yeah, it's correct. So it's asking in the energy absorbed in 3 seconds. So it means 3. So what is the final equation? Can anyone tell me? So in 3 seconds, what is the power absorbed? Oh, it's not asking the answer, I guess, but still, you can leave it. Minus 90 e raised to the power minus 40 is correct. Okay. So C part, ET. How do you find ET?
Integration power to dt.
Yeah, 0 to 3 PT dt. So solve it. Minus 90, 0, 3 e raised to power minus 40 dt. Correct. So what is the final value? Can anyone solve it, please? Okay.
22.4.
22.499. Okay, it's 22.5. Minus also.
Minus
Remember that.
22.4998.
Yeah. Great. Thanks, Anusuya. So 1.16. Now I'll ask Mayur. Mayur,
Yes, sir.
yeah. So let's solve 1.16 together. So what is it asking? It's asking to calculate P1 for each and every component, right? So can you tell me what is, let's start with P4. What is P4? Mayur? Okay, no response. Sejal?
Sir,
Yes,
80.
sir.
What is it? 80.
80.
80. Is it absorbing or is it delivering?
Sir, absorbing.
Absorbing, correct. 80. Let's tell me about P3. What is I?
So 4 ampere.
4 ampere, correct. So it's simply 12 into 4. So is it absorbing? Is it delivering?
So delivering to the
Delivering.
source P3.
Great. Let's talk about P2.
Yes, sir. It is delivering the power from the lower potential to higher potential, and the 48.
Okay, so P1. So how will you find P1? I don't want to solve using KCL. So what will we do? We will do law of conservation of energy. So P1 is what? Minus of P2 plus P3 plus P4, right? So can anyone tell me what is P1? Sejal, what is P1?
16.
16 watt, correct. Okay. Figure 1.17. Again, Mayur, I want you to solve it. P1 is given minus 205 watt. P2 is given 60 watt. P3 is 70 watt. P5 is 30 watt. Okay. So what is P4? How will we find P4, Mayur?
Minus 45. Sir, it's maybe addition of this all elements.
Addition. Okay. So we'll do addition then. Oh, okay. So you're saying it's P1 plus P2 plus P3 plus P5. Is it correct?
No, sir. No, it is not a method.
It is not? Okay. Anushya, whatever I written is correct or wrong? Or is there something missing?
So there will be a negative sign in front.
Yeah. Yeah. So when you solve it, what would be the answer? 45, right?
Minus, yes,
45.
minus into minus.
Okay. So what does it say? Is it absorbing or supplying?
Absorbing power.
It's absorbing. Okay, we have 7 minutes and 6 questions to go through. 1.18. Come on. Who will solve this? Poonam. Poonam? Amen.
Sir, is this we have to apply the KCL law?
No, not yet. You can apply if you know, but since it hasn't been taught yet, I don't think so. You have to apply it yet. So you don't have to apply it yet. And you can if you want to, but no. Without it, how will we solve it?
As per KCL, it will be 3 ampere. 2 plus 3 equal to 5. The currents entering the node will be same as current leaving the node.
Great, but I want you to tell me how will we solve it if we don't know KCL. Say, let's say I don't know KCL. Now convince me how is it 3 ampere? Anusuya, how will we do it?
So we can do it by the same way by using law of conservation of energy using powers.
Yes, law of conservation of energy, and we can solve everything, and then IS will come out to be 3 ampere. Okay. Yeah. 1.19. Oh, it's a very good question. Just remove this. Yeah. Okay, now tell me, Anusuya, how will we solve? No, not you. I'm asking again and again. Ame, are you online?
Yes, sir.
Yeah. How will we solve this equation? How will we solve this question?
Conductor, sketch the current waveform.
See, what is I in terms of Q? It's dq by dt,
Yes.
right? So what exactly is dq by dt for a waveform?
The slope.
Slope. It's basically the slope of this waveform. So let's draw it together. Ame, I want you to do it, so please be
But I
available.
don't know how.
We'll go through it. We'll do it together. So up till 2, tell me what is the slope?
1.
No,
Sorry,
it's not 1.
half. Not half.
It's not half. Oh, okay. What is slope? Slope is nothing but y2 minus y1 divided by x2 minus x1. Now tell me.
100 minus 0 upon 2 minus 0, so 50.
50. Great. So this is 50. Okay, now from 2 to 6.
Minus 2 to 6.
Yeah,
Minus 50.
minus 50. I hope you haven't opened the solutions yet. So yeah, 6. And then from 6 to 8.
50 plus 50.
Okay, plus 50. So what I've drawn is correct. Anusuya, is it correct?
Yes, sir.
Great. Okay, so 1.20. We'll solve it now. Poonam, are you online still?
Yes, sir, I'm online.
Yeah, so let's solve this question together. Okay, so it's asking in which one the device is source. So the device is the white box in between. So can you tell me how will we identify if a device is source or not? What is the source? Does it absorb power or deliver power? It delivers power, right? So a source delivers power. So in A, is it absorbing or delivering? Poonam, current is entering the positive terminal. Is it absorbing or delivering?
Sir, positive is delivering.
It's delivering. Ame, is it absorbing or delivering?
Sir, from positive to negative, it's absorbing power.
Positive. Okay, so A is absorbing. So A is not a source. Correct? Now B. Poonam, B.
The
Yes.
source.
Source, correct. Now tell me here. This is fun. So tell me, is it absorbing or is it delivering? And why?
Absorbing. Source.
It's a source. I don't think so. Tell me why is it a source? So if you see, the direction is given over here, but the current is negative. So what is the true direction? The true direction is this, right? Anusuya, am I right?
Yes, sir.
So it's entering the positive terminal. So is it a source or a sink?
It is a sink, it is absorbing.
Yeah, it's not a source. What about D? Poonam?
Sir.
What about D? So the current is leaving the positive terminal. It's a okay. Mayur. So the current is leaving the positive terminal for that element. What is it? Is it a source
It
or a
is
sink?
source.
Yeah, great. So it's 6. Okay, so I guess there are how many questions left? 3 questions left. So let's finish this. It's easy. So how much power is delivered by a 10 amp current source if it is open circuited? Oh, okay. Now I want Ame to answer this question. Ame,
Yes, sir.
yeah. So it's a current source and the terminals are open circuited. What is the what is the I mean what is the power it's delivering
So
to that
current in
terminal?
a open circuit will be 0. So power
Okay,
will be 0.
power will be 0. It's a current source.
Current source. But don't know, sir.
Anusaya.
Sir, if it is the open source, then the potential difference will be very high.
Potential difference is very high. So
So it tends to be in line perfectly.
great. So it's infinity. Ame, do you understand now?
Yes, sir. Yes, sir.
It's open circuited, so the potential difference is very high. So it's an open. It's the power delivered is infinity. Now B, it's shorted now. So what's the potential difference now, Ame?
0.
0. So what's the power?
0.
Okay, great. See, if a voltage source of 1 volt is placed across it so that the current enters the negative terminal of that voltage source. Now tell me what's the power it's delivering.
It's delivering, sir, 10 watt.
Okay, so it's minus 10 watt, right?
Yes, sir.
1.22. So we have a 10 volt voltage source. Same question now. It's open circuited. I mean, now tell me. I mean, if it's open circuited, current would be 0, right? So the power is 0. I now short it. So the current is what? I mean, Anusuya, I have shorted the terminals. What is the current?
Infinite.
Infinite current.
So the it's infinite. Now see, it's saying it has placed a current source such that the current enters the positive terminal of that voltage source. Now tell me what is the power it's delivering. Now just remember what is the power delivering I'm talking about.
So 10 watt power absorbed.
10 watt.
It's absorbing. So what? So in delivering, in terms of it, if I say it's delivering something, what would be?
Minus
What would it
10
be?
watts.
Minus
Yes.
10 volt.
Okay. Now the next question, last question. In moving from 1 to 2, let's say this is a terminal 1 and this is a terminal 2. It's saying a Coulomb charge changes its energy by 10 joules. Give the voltage of 0.1 with respect to 0.2 if the charge is positive and the energy is lost. Okay. So V is what? Delta omega by delta Q. Am I right? Hello?
Yes, sir.
Okay, 6-4. I think I will take the last 2 questions the next class because I don't think so. 2-hour class is enough already, so it'll take 6 more minutes. Are you willing for 10 more minutes? We can solve these 2 problems too, or do you want to continue in the next class? I'm okay with both. Nobody is responding and everyone is
Let's
leaving.
solve. Let's solve.
So we can solve
Yeah.
it now.
We can solve the problem, right?
Yes,
Okay,
sir.
let's solve. Now tell me, it's saying the so a charge is moved from point 1 to point 2 and it changes its energy by 10 joules. So its energy is changed by 10 joules. So this is 10 and the charge is positive. So if a charge is positive, what is the voltage? A coulomb means the charge is 1C and it's positive. What is the voltage now?
Negative, sir.
Negative. Charge is positive and energy is lost. Anusuya.
Positive, it is there.
Okay. So what is the voltage? Oh, okay. Let me write 1 to 2. That means it would be much more.
10 volt.
Okay. So the charge is moving from 1 to 2 and the energy lost is 10 joules. Okay. So we need to find out the voltage with respect to point 1. Sorry, of point 1 with respect to point 2, and it comes out to be 10 volt. So now similar analogy will do. And now it says the charge is positive and the energy is gained. What would be the voltage?
Minus 20.
Minus 10 volt. Similarly, we'll do for the rest of these. The charge is negative and the energy is lost. Anusuya, the charge is negative and the energy is lost. Yes. Last, the charge is negative and the energy is gained. Ame, you tell me.
10 volts.
Yes. Last question. In a certain two-terminal device, a positive current of 10 ampere enters terminal 1. And leaves from terminal 2. What is the power absorbed in the device when A voltage at 1 is 10 volts with respect to 2 volts? So the voltage is 10. And what is the power absorbed, Ame?
Is it an open circuit, sir?
Assume there's a, I didn't draw it, but let me draw it. Assume there is a some current source, let's say. Okay, it's delivering 10 amperes to this two terminals where the voltage difference is 10 volts. Now tell me between P12, what is P12? What is the power absorbed?
100
VI, right?
watt. 100 watt.
Watt. Great. Now it says the voltage at 2 is 10 volts positive with respect to 1. So it would become like this. So this would be positive and this is negative. What is the power absorbed?
Minus 100 watt.
Minus 100 watt. Because just a second, yeah, power absorbed in the device, right? See, the voltage at 1 is minus 10 volt positive with respect to voltage. So what is it doing is it's saying that now it's like this. So what exactly is the power absorbed? Power absorbed. Can you tell me? So if it's minus 10 volt, that means the polarity is reversed, right? So that means the voltage direction is opposite.
Okay.
Yeah. So it would be delivering power, right? Because this would be plus then and this is minus because this is minus. So polarity is reversed. So I'll write it like this. So if this is the case, then the power would be delivered, hence it would be negative and it would come out to be 10 minus 100 watt. Any questions?
No, sir.
So Anusuya, did you understand?
Yes.
Anyone else, if anyone has questions or any feedback, you can give me. So we are all learning over here. I'm also learning to teach. So if it's not good, trust me, it will get better. Just give me your feedback.
So when the next class is there?
So it would be Saturdays, every Saturdays 4 to 6.
So will the solutions be given to
Yeah.
us?
So the exercise solutions I'll provide you. I'll so the NPTEL team will convey the drive folder where I'll add these materials. So they'll convey that drive folder to you, and over there you can download everything.
No, but will the
I'll
steps be there or only the answers?
no. Whatever I've done in the class, I'll once again go through it, clear it, and then send it to you. You'll be able to understand all the step-by-step solutions.
Thank you, sir.
No worries. Any other queries or any feedback you can give? I mean, you can all
Thank you,
give.
sir.
Yeah.
Thank you, sir.
Don't say thank you. It's my job. Anyone else? Any feedback? Anusuya, any feedback? No, I don't think so. No. Poonam? Sejal? No one, right? Yeah, Poonam, yeah. Go ahead.
No, sir.
Okay, so we'll stop here and then we'll meet again Saturdays 4 to 6. I'll give you a fair. I'll provide you with this solution sheet, and then you can go through it once more. And if there are any problems, we can discuss in the next week's class. But please do go through this problem. It's very much required. I can't stress this fact enough. This 1.12b. It would be a refresher for you for your integration as well. So if I try to teach you integration in this class, then it would become hard for me to teach you this material that I've been given, right? So if you could go through this question and this is a refresher for your integration, so it would be very helpful to me too. So we'll discuss this question next class in detail. If you have any queries, we'll discuss. So thank you very much. Thank you for being patient with me, and see you in the next class. Bye. Have a wonderful day. Yeah, you can all leave now.
Thank you, sir.
Bye.
Bye, sir.
Bye.